All right. So this is Unit 5, Day 1 notes. We are getting into inequalities, graphing inequalities on a graph, and basically plotting points. So it's these days that you're going to be having here are basically small chunks of the bigger picture. Of course, Unit 5 day notes is 14 days, but they are like small chunks. So couple pages of notes on things that you kind of need to learn, and you can go, as quickly as possible through these or as slowly as possible through these, but please make your way through them if you are having trouble in ALEC. It really will help. All right, so graph the inequality below on the number line. With this particular, how I would, of course, your number line is going to be a little different. So -1, let's say 0, 1, 2, 3. It's going to be a number line like that. On Alex, I'm not sure how they would do it. If I had like 0, 1, 2, 3, I guess I didn't have to make this that as long. 4, 5, 6, something like that. Okay. So for this particular one, of course, this is the number that you're going to be graphing, 1. Okay. If it has a line under the inequality, it's going to be a closed circle. So in this case, at 1, we're going to have a shaded in closed circle. Okay. And how I would put the arrow is the same way. So you see how this looks like an arrow almost. The arrow kind of goes the same exact way as the inequality. If you put a line through it, it looks like an arrow going this way. And that is the way our arrow is going to go on ours. Okay, so this points in that direction, and that's the direction you're going to go for greater than. Greater than are all numbers bigger than. So 1, 2, 3, 4, 5, all those numbers are bigger than 1. So that's why that line is going to go that arrow is going to go that way. But that's the kind of the way I look at it. If the variable's on the left-hand side, the variable has to be on that left-hand side, then it will go the way it kind of looks like it's going. Same thing here. No line under is an open circle at 5. And as you see, this looks like an arrow going that way. Okay? Looks like an arrow going that way. So that's the way your arrow will go. Okay, and of course the left-hand side, that the letter has to be on the left-hand side there. Okay, and this looks like an arrow going that way, and that's the way your arrow is going to go. Okay. All right, so give the location of Paris as an ordered pair. Okay, an ordered pair has an X and a Y. X is always side to side. X is always side to side. So however you move side to side is your X value. Y is you're moving up and down. Okay, so if your Paris is here, I see Paris here. It looks like I start from your point of 0, then you move to the left, 1, 2, 3, 4. I move to the left 4, so that would be -4. Okay, so I move to the left 4, that's -4, and then I moved up 1, 2, 3, 4, 5. Up 5 is +5. Okay. So left and right are your X values. Up and down are your Y values. So give the location of Bern as an ordered pair. Bern, it looks like I started here. I moved to the right. 1, 2, 3, 3 actually. Sorry. 1, 2, 3. 4 is too far. 3 to the right. So that's going to be +3. And then I move down. 1, 2, 3. Down 3, -3. And hopefully you have printed these out. They are on your modules, Unit 5, Day 1 notes. All of the notes are on your modules. If you print them out and go over them with me, and we're going over them together, it makes it a little bit easier for you to kind of see what's going on, okay? It's hard to see here because it's kind of like faded, but if you printed your own out, you can kind of see it a little better. All right, so page 2. And it says plot using using the pencil on Alex. Plot the point 0, 5, 0, -5. So remember that side to side is your first number, that's X. It says move side to side 0. That means you don't go anywhere side to side. But we have to, for our y value, we go down 5. You go up and down for the second number. So in this one, 1, 2, 3, 4, 5 down, that would be our point, our first point, okay? Same thing here, use the pencil. 5, your x value goes left and right. This y value goes up and down. I'm going to go to left 5 and down 2. So 1, 2, 3, 4, 5 left, down 2. That is my second point there, okay? All right, so fill in table using this function rule. This is the rule. So basically, y equals negative 3x minus 5 is the rule. These values are input. I'm going to replace x with negative 6 first. So y equals negative 3. In place of x, I'm putting negative 6 minus 5. Okay, I can throw that in my calculator. Hopefully you have the calculator. This TI30X2S, it is at, you can find this at Walmart, Target, maybe even Amazon, but it's about $12. It is very, very, very useful. It is a wonderful investment. It is the only calculator that is approved all the way up through pre-calculus, and it is a very, very useful tool. I promise you this is a great investment. All right, so I'm going to put that in my calculator, negative 3 times negative 6 minus 5, and I got my answer 13 there. So here it would be 13. Again, right here, I'm going to replace x with negative 3. Put that in my calculator, and then for the next one, negative 3, I'm going to replace x with 0. And then I'm going to replace x with positive 3. Okay, so I replaced all of my x values here with these numbers. And then when I get my answer, that'll be the answers here. So I will do that. That'll be negative 3 times negative 6 minus 5. That's 13. Oh, I already did that one. Negative 3 times negative 3 minus 5, 4. Okay, so that will be that answer. Negative 3 times 0 minus 5, negative 5. My answer there. And finally, negative 3 times 3 minus 5, negative 14. Okay, that's what you do there. Negative 14. Good. All right, so here, same situation. You're going to replace x. So y equals 5x plus 1. You're going to replace x with all of these numbers. So y equals 5 times negative 1 plus 1. Y equals 5 times 0 plus 1. We're getting the answer. Y equals 5 times 1 plus 1. And y equals 5 times 2 plus 1. All you're doing is replacing x in this situation with first negative 1, then 0, then 1, then 2. Okay, put in my calculator or in your mind, 5 times negative 1 is negative 5. Negative 5 plus 1 is negative 4. So negative 4 is my answer there. 5 times 0 is 0, plus 1 is 1. Okay. 5 times 5 is 5, plus 1 is 6. So I got that. Again, you can put them in your calculator. 5 times 2 is 10, plus 1 is 11. I'm good with you putting in your calculator. Don't be ashamed. Put it in there. Get the answer correct. All right, so now last problem. They said, is this a solution? For each ordered pair, determine whether the solution of y equals 4. So y equals 4 is our problem. Okay, so if y equals 4 in this situation, basically anywhere where y is 4 is a solution. And if you can't really read that, again, it's easier if you print it out for yourself. I had to kind of write them again. They were very light. Anywhere where y is 4, it is a solution of y equals 4. This one is 0, 8. No, not a solution. 0, negative 1. No. Negative 9, 4. It says y is 4. Remember, this is your x and this is your y. Y is 4 here, so this one is a solution. And this one, x is 4, but that's not y. Y is negative 6 here? No. Okay. If it says y equals, then y has to equal 4. And then it makes it a solution. Everything else is not. In this particular case, it has 5x minus 8y equals negative 29. And it's asking for each ordered pair, determine whether it's a solution of this. So in order to tell whether this is a solution of this, you have to replace x with 6 and y with 5. So whatever number's here, this is 6 and this is 5. Remember, this represents your x and y. If I put 5 times 6 minus 8 times, in place of y, I'm putting 5, equals negative 29. If it comes out to be true, so if negative 29 is the answer to that, then this is a solution. So let's put in our calculator. Let's put 5 times 6 minus 8 times 5. Oops. I don't know why I did that. Push enter. Negative 10. This is negative 10 equals negative 29. Is that true? That is not true. So guess what? It is not a solution. Okay, let's go to the next one. Negative 1 and 3. So I'm going to replace 5 with negative 1. X, excuse me. X with negative 1 minus 8 times 3 equals negative 29. So it's saying negative 1 for x, negative 1. Negative 1 for x and positive 3 for y. Put in my calculator, 5 times negative 1 minus 8 times 3. Negative 29 equals negative 29. Is that true? That is true. So since it is true, then yes, this point is a solution. Okay? Now let's use 0 for x. Minus 8 times y is negative 4 equals negative 29. Put that in my calculator. 5 times 0 minus 8 times negative 4, and that equals 32. Does 32 equal 29? No. So since it does not, it is not a solution. So for this one, it's no. And then finally, 5 times negative 9 minus 8 times negative 2 equals negative 29. 5 times negative 9 minus 8 times negative 2, and that equals negative 29. And that equals negative 29. So that is a solution because it is true. Okay, that's how you find out if something is a solution. Just put it in, replace it, place the x and the y, and if it comes out to be true, it is a solution. Okay. All right, so find an ordered pair xy that is a solution of the equation here. Now, how do we do this? All right, so since they're asking you for a possible solution, they just want any solution that would fit within this problem. So we're going to pick any number you want. So I'm going to pick, let's say, 1 for y. Okay, so I'll have x minus 2. In place of y, I'm going to put 1. Okay, so basically what I'm saying is my y is now 1. I'm picking 1 for y. What would my x have to be in order for this to come out to be true? Or how can I solve? I need to solve now for x to get my x answer. Okay, so now that I have 1 in for y, I can get x by itself. So 2 times 1 now becomes 2. I'm leaving 6 alone. Now, in order to get x by itself, I have to add 2 to both sides. And you've done equations in math 3, hopefully. All right, so 6 plus 2 is 8. So my x value now is 8. So this is a possible point on this graph because I know when I put in 1, I got 8 out as my answer. Let's try another one. Just really, they just want 1, but I want to kind of do it again for you so you're not confused. So now imagine if I replaced x, I picked a number for x. I said 0. I want 0 for x. So my x is 0. I don't know what my y is, but my x, I'm going to say it's 0. 0 for x. Minus 2y equals 6. Okay? The 0 kind of goes away. So I'm going to bring negative 2y equals 6 down, divide by negative 2 to get my y value. So my y is going to be equal to 6 divided by 2, which is what? Negative 3. Okay, so now a point is 0, negative 3. So you can do that to find out what a point would be on the graph by basically just replacing either x or y with any number you want. So let's try it here. So we have negative x plus 6y equals 6. Okay, I'm going to choose a number for this. I'll say, let me say 0. So for y, I'm going to make y 0. Okay, so this is going to be negative x plus 6 times 0 equals 6. So now y is 0. So this now kind of cancels out because it becomes 0. Negative x equals positive 6, because this became 0, so it kind of went away. So now I would just divide by negative 1 or multiply, but divide by negative 1, and that becomes x equals 6 divided by negative 6. Negative 1 is negative 6. So negative 6, 0 is a possible point or solution for this equation. Okay, so just picking numbers that you want, and then once you pick it, you just solve the equation for the remaining letter. Okay, and that is it for Unit 5, Day 1 notes.